Welcome back to Zone Out Fun. If you find this video informative, please hit the like, subscribe, and notification buttons. Let's begin our exciting journey through what every 13-year-old should know about Earth science. Today, we'll explore the wonders of our planet and beyond. Earth science encompasses the study of various disciplines, including geology, meteorology, oceanography, and astronomy. From the depths of the ocean to the vastness of outer space, there's so much to discover and learn about our world. So, buckle up and get ready for an adventure of scientific exploration like no other. Earth science is the study of our planet and its processes. It's about understanding how the Earth works, from its geological features to its atmospheric phenomena. Geology focuses on the solid Earth, including rocks, minerals, and the forces that shape the landscape. Meteorology deals with the study of weather and climate, while oceanography explores the oceans and marine life. Astronomy examines celestial objects and phenomena beyond Earth's atmosphere. Together, these disciplines help us unravel the mysteries of our planet and the universe. Scientists use the scientific method to investigate Earth's phenomena. It's a systematic approach that involves making observations, forming hypotheses, conducting experiments, and analyzing data. By following this method, scientists can test their ideas and theories, leading to new discoveries and advancements in our understanding of the world around us. Whether it's studying the formation of rocks or predicting the weather, the scientific method is the foundation of Earth science research. Earth is composed of several layers, each with its own unique properties and characteristics. The outermost layer is the crust, which is divided into continental and oceanic crust. Beneath the crust lies the mantle, a semi-solid layer that extends to the Earth's core. The outer core is made of liquid iron and nickel, while the inner core is solid. These layers interact in complex ways, driving geological processes such as plate tectonics and volcanic activity. Plate tectonics is the theory that Earth's lithosphere is divided into large, rigid plates that move over the asthenosphere. This movement is driven by convection currents in the mantle, causing the plates to collide, separate, or slide past each other. Plate boundaries are areas where these interactions occur, resulting in earthquakes, volcanic eruptions, and the formation of mountain ranges. Plate tectonics is a fundamental concept in Earth science and helps explain many geological phenomena. Volcanoes are openings in Earth's crust where magma, gases, and ash erupt onto the surface. They can form at convergent plate boundaries, where one plate is forced beneath another, or at hot spots, where magma rises from deep within the mantle. Volcanic eruptions can be explosive or effusive, depending on the viscosity of the magma. They can have devastating effects on the surrounding environment, but they also play a crucial role in the formation of new landforms and the recycling of Earth's crust. Earthquakes are sudden movements of Earth's crust caused by the release of energy along fault lines. These faults are fractures in the Earth's crust, where rocks have slipped past each other. When stress builds up along a fault, it can cause the rocks to break and move, resulting in an earthquake. The energy released during an earthquake travels as seismic waves, which can cause shaking, ground displacement, and tsunamis. Earthquakes are a natural part of the Earth's tectonic processes and occur regularly around the world. Rocks are composed of minerals, which are naturally occurring inorganic substances with specific chemical compositions and crystal structures. There are three main types of rocks: igneous, sedimentary, and metamorphic. Igneous rocks form from the solidification of molten magma. Sedimentary rocks are created from the accumulation and cementation of sediment, and metamorphic rocks are formed from the alteration of existing rocks under heat and pressure. Minerals are the building blocks of rocks and have diverse properties and uses in our everyday lives. The rock cycle is a continuous process that transforms rocks from one type to another through processes like weathering, erosion, and metamorphism. It begins with the formation of igneous rocks through the cooling and solidification of magma or lava. These rocks can then be weathered and eroded into sediment, which is transported and deposited by water, wind, or ice to form sedimentary rocks. Over time, these rocks can undergo heat and pressure to become metamorphic rocks, or they can melt and return to the magma beneath the Earth's surface. The rock cycle is driven by Earth's internal heat and external forces like weathering and erosion, shaping the landscape over millions of years. Weathering and erosion are processes that break down and transport rocks and minerals on Earth's surface. Weathering refers to the physical or chemical breakdown of rocks into smaller particles, while erosion involves the transport of these particles by water, wind, or ice. These processes play a critical role in shaping the Earth's surface, creating landforms like valleys, canyons, and beaches. Weathering and erosion can be caused by natural forces like water, wind, and ice, as well as human activities such as mining, construction, and agriculture. Soil is a complex mixture of minerals, organic matter, water, and air that forms on the Earth's surface through the weathering of rocks and the decomposition of organic material. It provides a habitat for plants and microorganisms and serves as a medium for plant growth. Soil formation occurs over long periods of time through the interaction of biological, chemical, and physical processes. Factors such as climate, parent material, topography, and time influence soil properties and composition. Understanding soil formation is essential for sustainable agriculture, land management, and ecosystem conservation. The water cycle, also known as the hydrological cycle, describes the continuous movement of water between the atmosphere, land, and oceans. It includes processes such as evaporation, condensation, precipitation, infiltration, runoff, and transpiration. Water is constantly cycling through Earth's various reservoirs, driven by energy from the sun and gravity. The water cycle plays a crucial role in regulating Earth's climate, distributing freshwater resources, and sustaining life on our planet. Understanding the water cycle is essential for managing water resources, predicting weather patterns, and mitigating the impacts of climate change. Weather refers to the atmospheric conditions in a particular place at a specific time, including temperature, humidity, precipitation, wind speed, and direction. It is influenced by factors such as air pressure, solar radiation, topography, and proximity to large bodies of water. Weather patterns can vary greatly from one location to another and change rapidly over short periods. Meteorologists use weather instruments, satellite imagery, and computer models to forecast weather and study atmospheric phenomena. Understanding weather is important for planning outdoor activities, managing agricultural operations, and preparing for severe weather events. Climate change is the long-term alteration of Earth's climate patterns, including changes in temperature, precipitation, and weather extremes. It is primarily driven by human activities, such as the burning of fossil fuels, deforestation, and industrial processes, which release greenhouse gases into the atmosphere. These gases trap heat from the sun, leading to global warming and disrupting Earth's climate systems. Climate change has far-reaching impacts on the environment, ecosystems, and human societies, including rising sea levels, melting ice caps, more frequent and severe weather events, and shifts in agricultural productivity. Addressing climate change requires collective action at local, national, and global levels to reduce greenhouse gas emissions, transition to renewable energy sources, and adapt to changing conditions. Earth's atmosphere is a layer of gases that surrounds the planet and provides the air we breathe. It consists of nitrogen, 78%, oxygen, 21%, and trace amounts of other gases such as carbon dioxide, water vapor, and argon. The atmosphere is divided into several layers, each with its own unique characteristics and properties. The troposphere is the lowest layer and is where weather occurs. The stratosphere contains the ozone layer, which absorbs ultraviolet radiation from the sun. The mesosphere is the middle layer, while the thermosphere is the outermost layer, where the auroras occur. The exosphere is the outermost layer and gradually transitions into space. Earth's atmosphere plays a crucial role in regulating the planet's temperature, protecting life from harmful radiation, and supporting weather and climate systems. The oceans cover about 70% of Earth's surface and play a crucial role in regulating the planet's climate and supporting life. They are home to a diverse range of marine organisms and ecosystems, from microscopic plankton to massive whales. Ocean currents are large-scale flows of water within the oceans that transport heat, nutrients, and marine life around the globe. They are driven by a combination of factors, including wind, temperature, salinity, and the Earth's rotation. Ocean currents influence weather patterns, climate systems, and marine habitats, making them a key focus of study in Earth science. Ocean waves are rhythmic disturbances of the sea surface caused by the wind, earthquakes, or underwater landslides. They can vary in size, speed, and energy, ranging from small ripples to massive swells. Waves play a crucial role in shaping coastlines, transporting sediments, and providing recreational opportunities for surfing and sailing. Tides are the periodic rise and fall of sea levels caused by the gravitational pull of the moon and the sun. They occur twice daily and can vary in height and intensity depending on factors such as lunar phases, coastal geography, and ocean basin shape. Tides influence coastal ecosystems, navigation, and human activities like fishing and aquaculture. Astronomy is the study of celestial objects and phenomena beyond Earth's atmosphere, including stars, galaxies, planets, moons, asteroids, comets, and the universe as a whole. It explores the origins, evolution, and structure of the cosmos, as well as the fundamental laws of physics that govern the universe. Astronomers use telescopes, satellites, and other instruments to observe and study objects billions of light-years away, providing insights into the nature of space and time. Astronomy has deepened our understanding of the universe and our place within it, inspiring wonder, curiosity, and exploration of the cosmos. Earth's moon, Luna, is Earth's only natural satellite and the fifth largest moon in the solar system. It orbits the Earth at an average distance of about 384,400 kilometers and has a diameter of about 3,474 kilometers. The moon has fascinated humans for millennia, inspiring myths, legends, and scientific inquiry. It influences Earth's tides, gravitational pull, and axial tilt, as well as cultural practices and beliefs. The moon has been the target of exploration by humans and robotic spacecraft, with numerous missions conducted to study its surface, composition, and origins. Understanding the moon is essential for understanding the history and evolution of our solar system and the processes that shaped Earth and other celestial bodies. The Sun is the star at the center of our solar system, around which the planets, moons, asteroids, and comets orbit. It is a massive, hot, glowing sphere of gas composed mostly of hydrogen and helium. The Sun's energy is generated through nuclear fusion reactions in its core, where hydrogen atoms fuse to form helium, releasing vast amounts of heat and light in the process. This energy radiates outward through the Sun's layers, eventually reaching the surface and streaming into space as sunlight. The Sun is the primary source of light, heat, and energy for Earth, driving the processes of photosynthesis, weather, and climate. It plays a central role in sustaining life on our planet and is a key focus of study in astronomy and astrophysics. Stars are massive, luminous spheres of gas that emit light and heat through nuclear fusion reactions in their cores. They come in a wide range of sizes, temperatures, and colors, from cool red dwarfs to hot blue giants. Stars are born in clouds of gas and dust called nebulae, where gravity causes the material to collapse and form new stars. Over billions of years, stars undergo various stages of evolution, eventually running out of fuel and either fading away as white dwarfs, exploding as supernovae, or collapsing into black holes. Galaxies are vast collections of stars, gas, dust, and dark matter held together by gravity. They come in different shapes and sizes, from spiral and elliptical galaxies to irregular and dwarf galaxies. Galaxies contain billions or even trillions of stars, along with planets, moons, asteroids, and comets. They are the building blocks of the universe and provide valuable insights into its structure, history, and evolution. Earth's seasons are caused by its axial tilt and its orbit around the Sun. The Earth's axis is tilted at an angle of about 23.5 degrees relative to its orbital plane, resulting in different parts of the planet receiving varying amounts of sunlight throughout the year. When the northern hemisphere is tilted toward the Sun, it experiences summer, while the southern hemisphere experiences winter. As the Earth orbits the Sun, the tilt of its axis changes, causing the seasons to change. This tilt and orbit also influence the length of the day and the angle of the Sun's rays, affecting temperature, weather patterns, and the distribution of sunlight on Earth's surface. Understanding the seasons is essential for agriculture, navigation, and cultural traditions, as well as for understanding Earth's climate and ecosystems. Fossils are the preserved remains or traces of ancient organisms, providing valuable insights into Earth's history and evolution. They can range from the bones and teeth of dinosaurs to the imprints of leaves and footprints of early humans. Fossils form through a process called fossilization, which occurs when an organism is buried in sediment or other materials and undergoes mineralization. Over time, the organic materials of the organism are replaced by minerals, preserving its structure and form. Fossils can be found in rocks, sedimentary deposits, and even ice cores, providing clues about past environments, climates, and life forms. Paleontologists study fossils to reconstruct the history of life on Earth, from its earliest origins to the present day. Ecology is the study of interactions between organisms and their environment, including other organisms and non-living factors like climate, soil, and water. It explores how living things interact with one another and their surroundings, from individual organisms to entire ecosystems. Ecology encompasses a wide range of topics, including population dynamics, community structure, energy flow, and nutrient cycling. It also addresses pressing environmental issues such as habitat loss, pollution, climate change, and biodiversity loss. Understanding ecology is essential for managing natural resources, conserving biodiversity, and sustaining ecosystems for future generations. Conservation is the protection and preservation of Earth's natural resources, biodiversity, and ecosystems for future generations. It involves the sustainable use of resources, the restoration of degraded habitats, and the prevention of species extinction. Conservation efforts aim to balance human needs and activities with the needs of other living organisms and the environment. They include measures such as establishing protected areas, implementing regulations and policies, promoting sustainable practices, and raising awareness about environmental issues. Conservation is essential for maintaining ecosystem health, supporting biodiversity, and ensuring the long-term well-being of both people and the planet. Renewable energy sources, such as solar, wind, hydroelectric, and geothermal power, are sustainable alternatives to fossil fuels that reduce greenhouse gas emissions and mitigate climate change. They harness natural energy flows like sunlight, wind, and water to generate electricity and heat without depleting finite resources or emitting harmful pollutants. Renewable energy technologies have advanced rapidly in recent years, becoming increasingly cost-effective, efficient, and widespread. They offer numerous benefits, including reducing reliance on fossil fuels, creating jobs, enhancing energy security, and improving air quality. Transitioning to renewable energy is essential for addressing climate change, promoting economic development, and ensuring a sustainable future for generations to come. Environmental pollution is the introduction of harmful or unwanted substances into the environment, leading to negative impacts on ecosystems, human health, and the quality of life. It can take many forms, including air pollution from vehicle emissions and industrial activities, water pollution from sewage and chemical runoff, soil contamination from agricultural pesticides and waste disposal, and noise pollution from urban development and transportation. Pollution can disrupt natural processes, degrade habitats, and harm wildlife populations. It also poses risks to human health, causing respiratory diseases, cancer, and other health problems. Addressing environmental pollution requires comprehensive strategies, including pollution prevention, regulation, cleanup efforts, and public awareness campaigns. It's essential for protecting the environment, safeguarding public health, and ensuring a sustainable future for all. Humans have had a significant impact on the Earth's environment, altering landscapes, ecosystems, and natural processes in profound ways. From deforestation and urbanization to industrialization and overfishing, human activities have transformed the planet's surface and atmosphere, leading to environmental degradation, habitat loss, species extinction, and climate change. These impacts are driven by factors such as population growth, consumption patterns, technological advancements, and socioeconomic factors. Addressing human impact on the environment requires collective action at local, national, and global levels, including sustainable resource management, conservation efforts, and policies that promote environmental stewardship and social equity. By working together, we can minimize our negative impact on the planet and create a more sustainable and resilient future for all. Scientific inquiry and exploration are essential components of Earth science, driving discovery, innovation, and understanding of the natural world. They involve asking questions, making observations, conducting experiments, and analyzing data to test hypotheses and theories. Scientists use a variety of tools and techniques, from laboratory experiments and field studies to remote sensing and computer modeling, to investigate Earth's processes and phenomena. Exploration takes many forms, from studying rocks and fossils to exploring remote regions of the planet and beyond. It expands our knowledge of Earth's history, resources, and ecosystems, as well as the universe beyond our planet. By fostering curiosity, creativity, and collaboration, scientific inquiry and exploration are keys to unlocking the mysteries of our world and inspiring future generations of scientists and explorers. And that concludes our whirlwind tour of middle school Earth science. We've covered a wide range of topics, from the formation of rocks and the water cycle to the wonders of space and the impact of human activities on the environment. Earth science is a fascinating and diverse field that offers endless opportunities for exploration, discovery, and learning. Whether you're studying rocks, weather patterns, or the stars, there's always something new and exciting to discover about our planet and the universe beyond. So, keep asking questions, keep exploring, and keep seeking to understand the world around you. Remember, the journey of scientific discovery never ends.